Okay, velocity vectors. Well, remember, a vector is something that has both magnitude and direction. Okay, so in this case, I've got a vector going 4 meters per second east, a velocity. Okay, and I'm going to scale this so that 40 centimeters is equivalent to 4 meters per second. Okay, vectors can be added or subtracted, and if it's in the same plane, that's a pretty easy equation. Let's look at some examples. So I've got my 4 meters per second east. And let's say I'm paddling in a canoe 4 meters per second, okay? And I'm paddling with the current, and the current is 3 meters per second east. Well, that's a pretty simple addition problem. 4 meters per second east plus 3 meters per second east is 7 meters per second. That's my total vector, okay? It's also pretty easy if I have vectors going in opposite directions. I just subtract the second vector from the first. So I'm paddling now not downstream, but I'm paddling upstream with the current going against me. So my 4 meters per second east is being countered by a vector that's going 3 meters per second west. I'll try to be more accurate there. I'll probably be right about there. So if I subtract 3 from 4, I get 1 meters per second east is my total vector, okay? Now those are pretty straightforward, and sometimes you'll see problems like that, but vectors oftentimes are not moving either in the same direction or in the counter direction, but they're often moving at right angles. So now let's take my canoe, and now let's say I'm not going up or down the river, but I'm going across the river, okay? And here I'm paddling my canoe 4 meters per second east, but the river's flowing south, and it's flowing 3 meters per second south. Okay? Well, now when I add my vectors, I don't just get a smaller or larger vector, I actually get a vector that at a different angle, at a different direction. So when I connect my two vectors, I make a triangle. Okay? And now to calculate this velocity, I've got to do a little math. And since I have a right triangle, I can look at these values. So I've got this value and this value. If I have this value squared and this value squared, it's going to equal this value squared. So let's go ahead and write that formula. A squared plus b squared equals c squared. And that's the value I want to find right there, is c. Okay? So if I go ahead and solve that, I've got 4 squared is 16, 3 squared is 9, and that equals 25. Well, 25, the square root of 25 is 5. So my new vector here is 5 meters per second southeast. And that's how you solve vector velocity problems.